Hi everyone, welcome back. So in this video, I'm going to show you guys a DC analysis of a common emitter transistor amplifier shown on the left here. All right, and in this question, we're asked to figure out what IC is. So IC is the collector current, and what VCE is. That's the voltage between collector and emitter of this transistor Q1. Given that beta is 100 for Q1. All right. Okay, so as usual in questions like this, first thing you gotta do is to start labeling currents and voltages so that we know what we're talking about. So first, I'm going to label some currents. So okay, so this is an NPN transistor. So this is the emitter, right? So obviously this part is IE, right? And you're going to have current coming down into the NPN transistor and also from here into the base of the transistor. So you're going to have a current, you're going to have a current IC going that way, yeah, going from left to right and then top to bottom. And then you're going to have a current IB. So this is going to be IB. So that's IC, IB, and this is IE. Okay. So in terms of voltages, we have a few here. So we have VCC. So it's positive that way. VBB is also positive that way. And okay, so since this is IC is going downwards, so that means positive VRC is up. All right, so positive VRC is up. And what else? Okay, so RB here. So if IB is going in that direction, that means positive RB is defined as that direction. All right. And finally, for the VCE, since current is coming down that way, so VCE is defined as that way. So that's VCE. All right. So I think that's all the nodes labeled with voltages. All right, so now let's start writing some equations. So let's have a look at this loop here. Oh yeah, so there's one more here. That's VBE. All right, so VBE is, okay, this is NPN, so the transistor is in forward active mode, which means the base emitter junction must be forward bias, right? Which means P needs to be attached to a plus, and E needs to be attached to a lower potential. All right, so VBE is that one. All right, so that's VBE. So if you notice in this loop, you have VBB, VRB, and VBE. So you can write an equation for the loop. Okay, so I'm going to call that the base loop. All right. All right, so the base loop is basically VBB. I'm going to use a subscript VBB. Is equal to VRB plus VBE, right? Okay, so that's our first equation for the base loop. Well, we actually know everything. The only thing we don't know is VRB, so we can straight away work that part out. So therefore, VRB is equal to VBB minus VBE. So that's 1.5 volts minus 0.7 volts, right? So that is equal to 0.8 volts. All right, so that's 0.8 volts. So that's our VRB. VRB is this voltage there, all right? Okay. Okay, so with VRB, we can then now work out what IB is. Yeah, IB is this current there, all right? So what is IB? Well, IB through Ohm's law, okay? I equals V over R. So V here is VRB divided by the RB, right? So that's going to be equal to 0.8 volts. 0.8 volts divided by 100K, all right? So 0.8 divided by 100,000. So that's equal to 1, 2, 3, 4, 5, 6. So that's 8 microamps. 8 microamps. All right. So now we have IB. So we have IB. All right. So what else do we need? Well, we need to work out what VCE is. So we need to know what is the voltage up there, because we know this is 10 volts up there, right? So VCC is 10 volts. That's 10 volts up there. So the whole node from here all the way down to ground, it's going to be 10 volts. That's what this means. All right. Okay. So then it's quite easy to work out. Well, as long as we know what IC is, this is IC, right? If we know what IC is, then we'll know what VRC is through Ohm's law. And once we know what VRC is, then we can figure out what VCE is. So the equation on the VCC side, if you like, all right, the VCC side, the VCC is here. Well, it just means that this part is 10 volts. So that means this part here, right? Okay. So VCC is simply going to be equal to VRC plus VCE, right? So that's the equation for this part, yeah, for this part, because it's VCC at the top, and then you have those two conditions. So so that will be the equation for the top part. Now, we know what VCC is, that's 10 volts. We don't know what VCE is. We don't know what VRC is, but we know that VRC is equal to, through Ohm's law, V equals IR. So it's going to be IC times RC, right? Okay, so how do we figure out what IC is? Well, we have IB, and we have the equation for beta, so we can work out what IC is, all right? So here, IC is simply equals to beta times IB, all right? So that's going to be 100 times 8 microamps. All right. So that's going to be 800 microamps as an answer. All right. So that's 800 microamps. Okay. So now that we know what IC is, we can then substitute back into this equation to figure out what VRC is. All right. All right. So let's do that. So VRC is equal to IC, which is 800 microamps, times RC, which is 10 kilo ohms. All right. All right. So now that we know what VRC is, we can substitute back into this equation. Then, therefore, we can work out what VCE is, which is the answer we're looking for, the other answer that we're looking for. All right. So we can work out what VCE is, which is VCE from here, yeah, from here. So VCE is equal to VCC minus VRC. All right. So that's going to be equal to, sorry, let me just write straight away there, is equal to VCC is 10 volts. So it's going to be 10 volts minus VRC, which is 8. So therefore the answer is 2 volts. All right. We're done. So that's the answer for IC. This is the answer for IC. And this is the answer for VCE. So 800 microamps and 2 volts. All right. See you guys in the next video.